Do you prefer a soap that is chemical-based or one that is made from natural ingredients?
Of course, I would prefer the natural ingredients because it's less riskier and safer for the skin. Because if we use products that are based on chemicals, it might be risky because not all of our skin types are suitable or on par with the chemicals that we use.
Hi, what is your name?
My name is Jesseline. Yes. I've tried handmade soap before and I like how gentle it felt on my skin. Maybe coffee grounds because they can scrub the skin and smell nice.
Hi, sorry for interrupting. What is your name?
My name is Kenji. Almost every day. It depends how often I cook eggs. Huh? I never heard this before. Of course, the natural one.
A very good morning to the honorable judges, teachers, and fellow participants. We are here to present our project entitled Eggshell as a physical property modifier in everyday use household products. Our idea began with a simple question. What if waste could be transformed into something useful? Let us first look at the household waste problem. Every day, used cooking oil and eggshells are cut properly. When poured into drains, used oil pollutes waterways. When dumped in landfills, eggshells decompose slowly and add to solid waste. Together, these contribute to serious environmental pollution. At the same time, commercial soaps often contain synthetic chemicals, fragrances, or microbes. These ingredients may cause skin irritation for sensitive users and are also harmful to the environment because they are non-biodegradable. This is why there is a growing demand for eco-friendly skincare products that are gentle on the skin and safe for nature. The purpose of our project is threefold. First, to recycle household waste, namely used cooking oil and eggshells into a functional soap. Second, to create a natural soap with cosmetic benefits, exfoliation from eggshell powder, antibacterial properties from lemongrass, and moisturizing effects from the oil. Third, to promote sustainable chemistry and environmental awareness through upcycling. With that overview, let me now invite my teammate to explain our methodology in detail.
Thank you. I will now present the methodology of our project. We begin with the preparation of key ingredients. For the lemongrass extract, 50 grams of fresh lemongrass was washed, chopped, and boiled in 200 milliliters of water for 15 minutes. The liquid was filtered and cooled. For the eggshell powder, we collected eggshells, removed the inner membrane, dried them under sunlight until brittle, and ground them into fine powder stored in an airtight container. Next, we move on to the soap base preparation. We weigh 5.63 grams of sodium hydroxide pellets. At the same time, we infuse 6.56 milliliters of distilled water with 3 butterfly pea flowers, giving the liquid a natural blue tint. This butterfly pea water was then mixed with the lemongrass extract. Sodium hydroxide was slowly added to the mixture until it dissolved completely, forming a lye solution. The next step was combining oil and lye. We filtered 131.25 milliliters of used cooking oil and gradually mix it with the lye solution. The mixture was stirred continuously until it began to the trace stage, similar to pudding. Finally, we carry out the enhancement and molding. 2 grams of eggshell powder and optional natural colorants were added. The mixture was poured into molds and left to harden for 48 hours. In addition to soap, we also explore bioplastic production. We mix 10 grams of starch, 100 milliliters of distilled water, 3 grams of glycerol, and 5 milliliters of 5% acetic acid. This mixture was heated to 90 degrees Celsius until it gelatinized. 3 grams of eggshell powder were added before casting the mixture into molds. It was dried for 48 to 72 hours before the casting. This completed our methodology for both soap and bioplastic. Now, let me hand over to my teammate to present our findings, reviews, and conclusion.
Thank you. I will now share our findings and conclusion. For the soap, the results were very encouraging. The product showed good cleansing ability, effective exfoliation from the eggshell powder, antibacterial and refreshing effects from lemongrass, and moisturizing properties from the reused cooking oil. Importantly, users with sensitive skin reported no irritation. This is highly significant because it aligns with Sustainable Development Goal 3, good health and well-being. Skincare is not only about appearance, but also about health, safety, and confidence. By providing a gentle, natural, and eco-friendly product, our soap contributes to better skin health. Moreover, promoting safe and ethical skincare solutions supports community well-being, responsible manufacturing, and awareness initiatives that benefit society as a whole. For the bioplastic, the results were only partially successful while it formed correctly. It lacks strength and flexibility, meaning further improvement is needed. We also consider the relevance of this project to skin health. Globally, about 35.6% of people suffer from allergies, with most experiencing skin reactions. In the United States, 41.7% of adults report allergies, with nearly half involving the skin. In France, 20% of adults report allergies, and more than half involve skin irritation. Here, in Malaysia, a study revealed that 13.4% of children have atopic dermatitis, and nearly half of dermatitis patients show sensitivity to allergens such as nickel, propolis, cobalt, formaldehyde, and parabens. This highlights the urgent need for gentle, natural skincare products that also support health and well-being, as emphasized by SDG 3. We also gathered user reviews of our handmade eco-friendly soap. The feedback was overwhelmingly positive. Users liked that it was made from reused kitchen waste, reducing pollution while providing a healthier skincare option. In conclusion, our eco-friendly soap successfully demonstrates how waste can be upcycled into useful products. It is sustainable, safe, and practical. While our bioplastic require more development, the soap itself is proof that science can create solutions that protect both people and the planet. With this, we hope our project inspires greater awareness of sustainable chemistry, responsible waste management, and the global call for better health and well-being under SDG 3. Thank you.